Welcome to my presentation. In this presentation, let us see how we can find the determinant of a 3 by 3 matrix. So let me write that example down here. We have solved this example in my previous presentation, but I'm going to write the minors and cofactors here one more time. The matrix A, which had elements of this type, are as follows: -3, 2, 1, 4, 5, 6, 2, -3, 1. This is the matrix we had, and we have seen that for this matrix the minors and cofactors were as follows. So the minors were M11 was 23, M12 was -8, M13 was -22. I'll try to write the cofactors on this side in just a minute. Then we have M21 as 5, then M22 as -5. Let me clean this thing up a little bit. M22 is -5, and then M23 as 5. Then M31 is 7, M32 is -22, and M33 is equal to -23. Those are the minors. And the cofactors we found were as follows. C11 was 23, then C12 was 8, and then C13 was equal to -22. Then C21 was equal to -5, C22 was equal to -5, and then C23 was equal to -5, and then C31 was equal to 7, and then C32 was equal to 22, and then C33 was equal to -23. So these are the minors and cofactors which we found in my previous video presentation. So please look at that for more details in there. The point here I want to make is as follows. To find the determinant, we can either expand it by a particular row or expand it by a particular column. We cannot take all the rows and all the columns, but we can take a row and then find the determinant, or we can take a column and then find the determinant. So in this example, I'm going to do two things. I'm going to expand it based off the second row and based off the first column. And we have seen in my previous example, by taking the first row, we were able to find the determinant as follows. Taking the first row, I'm right here. Taking the first row, we found the determinant as being equal to determinant of A can be written out as A11 C11 plus A12 C12 plus A13 C13. And since we know the values of C11, C12 and C13, which are 23, 8 and -22, we'll pick those values here and see what we get. The value of A11 was -3 times -22 plus A12 was 2, and then the value of C12 was 8, C11 was, this one was, this is negative, this was a positive 23, sorry about that. Negative 3 times positive 23 plus 2 times positive 8, like that, plus 1 times A13 was 1, and then C13 was negative 22. So when we expanded this came out as the determinant of A was equal to negative 75. And we have seen this one. We have seen this one in my previous video. Now, what we want to do now is, what if we were to expand it by some other row? Let's say let that some other row be the second row this time. Second row. If we were to expand by second row, will we get the same determinant, or will we get will we get the same value for the determinant, or will we get a different value? Let us see. So the determinant there can be written out as A21 C11 plus A22 C, this should be A21 C21, A22 C22 plus A23 C23. We know the values of A21, A22 and A23, and those values are as follows. That's going to be the determinant. We can write that as A21 was 4, and then the value of the cofactor C21 is going to be negative 5, and that's what we have from the value above. And then A22, the value is 5, and then C22, the value is negative 5, and then A23, the value is 6, and then a C23, the value is negative 5. Therefore, when we expand this, we're going to get 4 times negative 5 is negative 20, and then 5 times 5 is negative 25, and then 6 times 5 is negative 30. Therefore, when we combine all of this, the determinant of A is going to be equal to negative 75, right? Same, no matter which way we do this, the value is going to be the same. The value of the determinant is going to be the same. When we expanded it based on the first row, we got the determinant as equal to negative 75. When we expanded it based on the second row expansion, we got the determinant as being equal to negative 75 as well. What if we were to change the rows and then go to a column this time? Let's say we want to expand it by the first column, expanded by the first column, and then when we expand it by the first column, will we get the same determinant? We'll see. And then the way to write this one out is as follows, isn't it? The determinant of A is equal to A11 C11 plus A21 C21 plus A31 C31. We are going by the first column this time, and the value of A11 is negative 3. The value of C11, which we found from above, is going to be equal to 23, plus A21, the value is 4, and then C21, the value is negative 5, and then the value of A31 is 2, and the value of C31 is 7. When we expand this one out, negative 3 times 23 is negative 69, plus 4 times negative 5 is negative 20, and then 2 times 7 is going to be equal to 14. And when we simplify this, negative 69 plus negative 20 plus 14, the value comes out as negative 75. So therefore, the determinant of A is equal to negative 75. If we want to travel along the row, we want to travel along a particular row, not all rows. We want to travel along a particular column. We can travel along a particular column, just one column, not all the columns. So no matter which way we travel, whether we travel along the rows or travel along the columns, to find the determinant, we can the value of the determinant is going to be the same. In my next presentation, we shall look at some more examples related to finding the determinant of a matrix.